do we solve first order ordinary differential equations that involve integration by parts? Must be interested or interesting to find out in this case, right? Now, of course, based on this problem here, we could actually solve these equations quite easily. So I'm going to show you one of the methods that one of my students have suggested, Niels in this case, so I would like to give a credit to him. All right, thank you very much, Niels, on this. So I'm going to present his suggestion on this. Right? So to solve this using integrating factors and at the same time using the definitions of hyperbolic function. Right, let's get started. Right? So from here, we're going to start off by working out its integrating factor. We can recognize this format directly because it's already in the form that we can work out the integrating factor. So the integrating factor, I'll just label as x in this case, ix. That will be given by the exponential. Okay, hold on. I think I wrote down the notations wrongly because this is a function of y in terms of t. What we are trying to find here at the end of the day is a solution y in terms of t here. So we will let our integrating function in terms of variables t here. So that is it equal to integrating cosine, cosine, I keep writing cosine here, sorry about that. That is cotangent, integrations of cotangent hyperbolic, t respect to t here, dt. Alright, now that's what we have. And then that require a bit of recollections on how to integrate cotangent. So just to recap, cotangent is actually given as cotangent hyperbolic is given as, I keep on writing x because I'm so used to the x here. Integrating a cotangent is the same as integrating a cos hyperbolic over a sine hyperbolic function. Now, this could be solved quite easily using substitutions. Here, we can actually write that down as, so by using u equal to sine hyperbolic t, we can easily integrate this. So the integrations for this will be the same as natural log of sine t, right? And then here we don't really need to put in modulus here because our intention is on finding out the integrating factors. But if you like to explore more on whether this sine hyperbolic is a positive functions, you can go ahead and sketch out the graph. Right? Of course, some of you will remind me to put a plus c there, yes. But in this case, we will omit the c at this point. We are just interested to get this. So therefore, it will be the same as exponential ln sine t. Okay, and then simplify that. That will give us a sine hyperbolic t. Right. I hope that is clear. And then once we have this, as usual, we are going to substitute this one back into here. That will be a sine t dy dt plus a sine t by cotangent hyperbolic t, and then a y should be equal to 2 exponential 3t here. Now let me put a fencing here to show the separation. Alright, now that's what we have. Now of course at this point you can further simplify that. That will be a cos hyperbolic t y equal to 2 exponential 3t. And then you can quickly recognize this one more time. It looked like a product rule. So this is u, if you like to call that. This one must be dv dt, and then this one is a v Is that a v in this case? Let me see. If that is a u, that oh sorry, this one this time I make a mistake here. This part is du dt. So if you differentiate this, we will get ourselves. Excuse me. We will get ourselves du dt of sine would give us a cosine hyperbolic t, whereby this will be our v. So dv dt, dv dt is actually dy dt, right? So that will be quite obvious in this case. So just make sure that you recognize the term u and v. So from here, we can deduce that this is basically can be simplified as a sine a t multiplied with y. Then that should yield 3t here. Okay, so that's how we are going to okay, let me see if I miss. Oh, yep. Okay, I just recognized my mistake here because just now when I multiply both sides by it, I have multiplied my it over here, but I have forgotten to multiply my it over here. So just let me make the correction here. So there should be a sine t here. Yeah, that's where I miss out. Sorry about that. Just let me put that in. So there's a sine t here. That's the part that I miss out. So now we are okay. Yeah, it's always good to check. All right. So that's one thing to pick up the mistake. So this is a complete equations now. So from here, we can in order to integrate this, it's always good based on a new suggestion. We can actually write this in or using the definitions of sine hyperbolic. So definition for sine hyperbolic is half et minus e negative t, and then that can be simplified to, if you want to simplify that, that is actually 4t minus e to t. And then finally, we're going to perform an antiderivative. So we say that the sine t y is actually equal to the integrations of this expression with respect to t here, and then that would yield 1/4 of 4t and then a half of e to t, and then don't forget we have the c. And then there you have it. You can leave it as it is, or if you like, you can leave it in the exponential form also can. So at this time being, I will just leave the answer as it is, as 1/4 e4t minus half e to t plus c. Now that will be our solution, general solution. At this point, I should point out this is a general solution to this problem here. Alright. Now, we also given the initial condition, so that shouldn't be a problem. All we need to do is substitute the t and y into this expression. So if you substitute t and y as equal to 0, we would be able to recognize that very quickly the c is actually a 1/4. So this is 0. So negative 1/4. So c is actually 1/4. So by substitute this into here, we will be able to obtain c equal to 1/4. Therefore, I can conclude the yeah, maybe I would write down, okay, this is a general solution. Yeah, maybe I'll keep it as c at this point. And then I'm going to write down the specific or particular solution. Now, at this point, I'm going to write down sine t y equal to 1/4 for t minus a half e to t plus 1/4. So this is the particular solution, or sometimes I would like to call it a specific solution. based on the conditions given. So I hope that is useful. All right. So I'm going to show you another methods where we can achieve the same result. Okay, the same result, but by using a longer methods, integrating by parts. Okay, let's see whether that works. Okay, so just let me clean this up. Okay, let's look at this. Same problem, but solving it using integration by parts. Okay. In this case, we have already found out our ix, which is I wouldn't go through the process one more time. In this case, it should be very obvious that it's a sine t here. Okay, I keep on making the same mistake here. It's supposed to be functions of I with respect to t here. So that is our integrating factor. And then from here, we also recognize that we can describe this whole expression in this form, which is a sine ht, pretty much the same as what we have obtained in our previous section, 2e3t sine t here. Now, instead of using the definition here, I'm going to apply integrations by parts on my right hand side expressions here. Okay. So now I'm going to show you how to actually perform integration by parts for this, because this is, in order to get a solution, sine ty must be the same as the integration of this one here with respect to t. So for this point, we're going to carry out integrations by parts. This is just the notations I'm using. So how are we going to apply integration by parts to achieve the same result that we did by using the definitions of hyperbolic function in this case? So I'm going to consider this now. I'm going to consider 3t sine t dt. So by considering this, we're going to perform the integrations by parts. Now, up to you which variable you want to choose to integrate. In this case, from my point of view, I would like to choose sine t for my integrations. It's easier. We don't have fractions to handle. So therefore, if I integrate sine hyperbolic t, I should be able to obtain a cos t quite easily. And then that is what I have if I apply integrations by parts. I would end up with e3t cos t dt for my first step. Yeah, my first stage. This is how it looks like. And then of course, I'm going to further my integrating by parts on this section here. So this section, I'm going to apply another time integrations by parts. So this is how it looks like. I'm going to put a big bracket here. There will be 3t sine hyperbolic t minus of 3e3t sine hyperbolic dt. Alright, now that's how it looks like. If I simplify that, that would basically look like 3t cos t minus 3e3t sine hyperbolic, and then of course don't forget I have a 9 here, e3t sine hyperbolic dt. Right. Now that's what I'm getting at this point here. And then of course my intention is to actually get e3t sine, but I found that I do have both of this term this side, so I can actually transfer this one over to the other side. I have myself a 8 d3t sine t dt. That will be the same as e3t you can actually write as negative e3t sine t minus cos t here. I just want to get rid of the negative. That's the reason why I keep it this way. Here I omit the c at this point. So therefore, I think if you are interested to get 2 times of this, so maybe I'll keep the 2 there for ease of substitution in a while. Now that will be a 1 over 4 e3t sine t minus cos t at this point. So this is how it looked like for this expression here. This integration is the same as this. Okay, now we are almost ready in this case. Right? Now all we need to do is just simplifying this, if you like. So that is now we're going to apply the. You can leave it as this form in the hyperbolic form if you want. So if you leave this as a hyperbolic form, then I would just finalize the answer as from this section here. I would say that sine t y will be the same as a quarter e3t sine t minus cos hyperbolic t plus a c. And then there you have it. That is my general solution. Yeah, that's my general solution. And then if you substitute these conditions into here, you would also find out that the c is basically 1 over 4. Right. So that part we're going to check it in a while. But at this point, my intention is to prove that by using the definition directly, like what Neil suggested, we can also achieve the same result if we use integrations by part. So let me finish up the last part. We can convert everything to its definition. So that is actually half et minus e negative t minus a half et plus e negative t here. Alright. So I'm going to erase off this section first. We will come back to that in a while as we conclude. Right. So by simplifying this, I'm going to write it down here. We don't have enough space here. So by simplifying this, we will be able to find out. So in this case, we have the half t. Do I have a half t here? Do I miss out anything here? Just let me check in case I miss out anything. So just now when I factorize this, I forgot to put a 3 in front. Okay, so let me touch up my arrow for a while. So in this case, I think I miss out that there's a 3 there. So 3 sine hyperbolic t, and then there should be a 3 here. Alright, now we are good. And then therefore this part will be a 3. Okay, so therefore there's a 3. Right, now we are good. So from here, if we simplify this, we will get a et, and then the other one we will also be able, we will get a negative 2 et. So negative 2 et here, and then this part we will get a et. So that will be negative 1 over 4 e3t, and then this one, just let me check properly, that is a et, sir. And then the other one is negative e negative t. And then finally, if you simplify that, you will get 4t minus e2t plus a c, of course. Alright, so that's how it looked like. As you recall from the previous working, the answer, the general solution for this is sine t y is equal to 1 over 4 e4t minus 1 over 2 e2t plus 1/2. Yeah. So this is what we have, and then this is what we have currently at this point. If you are good with this, then you would notice straight away at this point, this section is the same as this. So therefore, I can conclude that we are able to achieve the same general solutions by using integrations by part. Therefore, I can just conclude that saying sine t y is the same as e4t minus e negative 2t here plus a c. Okay, just let me check if I get anything wrong here. That is a 1, that is a 4. Alright, I make another mistake here. Just let me touch up my mistake here. I think there's a 2. This is 2e. 2e negative 2, sorry, negative t. Yeah, negative t. Not negative t, sorry. Okay, hold on, just let me correct that. This one will be, because if you combine them, that will be a 2t. Alright. Now because of that, I think I make another changes here. So that will be 2. In this case, that will be a 2 e2t plus a c, which is exactly the same as this. If we try to simplify that, that will be the same as quarter of e4t minus half e2t plus a c. Again, exactly the same as how we can obtain that directly from the definition. Of course, in this case, I would like to make a remark saying that New's method is far more better than the integrations by parts that we are showcasing in this case, but it's part of the revisions for some of you who are interested to challenge yourself in this case, right? So just let me check one more time in case I miss out anything. Yep, correct. Just let me make one more correction. Okay, sometimes it's quite easy to make a mistake here. So there's minus 2 here. So I think I missed out that. Other than that, everything else should be correct here. So I hope that has been informative in your studies of integrations and then solving first order ordinary differential equations. Right? Until I see you guys again, don't forget to subscribe and then press the notification bell for the latest video. Right? Thank you.